Hey everybody, welcome to Algebra, Section 8.5, FOIL Factoring. By the end of this lesson, you should be able to factor polynomials in the form of x squared plus bx plus c. You should also be able to use sign theory to help you with that FOIL factoring, and you should also be able to factor completely. So let's do a real quick review of FOIL. So here we have two binomials, x plus 4 times x plus 3. So FOIL stands for first. So I'll do the first term times the first term, which gives me x squared. Outer, so I'll take my furthest left term times my furthest right term, so x times 3, which is 3x. Then the inner, I take my two terms that are in the middle, so 4 times x. And then last, so I'll take my last term in the green parentheses times my last term in the purple parentheses, which gives me 12. And then you double check for like terms. So 3x and 4x are like terms. So you combine those and you make x squared plus 7x plus 12. That's the FOIL process. So now let's talk about how to undo that FOIL process. So first off, it has to be in this format. It has to be x squared with nothing in front of the x squared. So x squared is always the first term. And then bx plus c. So that means something in front of an x and then something without an x. So if it looks like that, this is how we're going to factor it. So let me be clear about this. Three terms. First one is x squared. The second one has to have an x, and the last one can't have an x. So what we want to do is we want to find out what two numbers multiply to be c but add up to be b. So take a look at this, for instance. So I'm looking for what two numbers can multiply to be 6 but add up to be 5. So let's think about that. What two numbers can multiply to be 6 but add up to be 5? So let's see, what numbers multiply to be 6? Well, 2 and 3. 2 and 3 add up to be 5. So that's our numbers, 2 and 3. So what we do is we write our answer as x plus 2 times x plus 3. Okay? Now, once you get it factored, if you want to double check it, you're certainly welcome to do that. All we got to do is just FOIL it back together. So x times x times 3, 2 times x, 2 times 3. If you add up your like terms, you get x squared plus 5x plus 6, and that's exactly what we started with. So we know we did it correctly. Let's do a few more examples. So check out these three examples. All of them are in the correct format. There's three terms. The first term is x squared. The second term is a number with an x, which there doesn't have to be a number. It could be a 1 there. But then the last term does not have an x. So all three of these problems fit the right format. So let's take a look at the first one. We're going to ask ourselves, what two numbers multiply to be 14? Okay, always look at the c term first, but add up to be 9. So the first thing that jumps off the page to me is 14 is 7 times 2. Okay, so if I take 7 and 2 and I add them up, does it make 9? It sure does. So my first guess was the right one. So the two numbers I'm looking for are 7 and 2. That makes my answer x plus 7 and x plus 2. Now, if you switched it around and said 2 and 7, you could say x plus 2 and x plus 7. Nothing wrong with that. If you're multiplying, you can switch up the order, and it's no big deal. Let's try it again. What two numbers can multiply to be 12 but add up to be 13? Well, 3 and 4 multiplies to be 12. That adds up to be 7, so that's not it. 6 and 2, that multiplies to be 12, but it adds up to be 8. So that's not it. The only other one is 12 and 1, and those add up to be 13. So that's the pair of numbers that we're looking for. Now, oftentimes people will miss out on the number and 1 as an option. So don't forget that. But since we found the right numbers, that's our answer. X plus 12 times x plus 1. Okay, let's go ahead and take a look at our last example here. So we're looking for two numbers that multiply to be 24, but add up to be 10. So let's see, 6 and 4 multiply to be 24. Do they add up to be 10? They sure do. So that's our answer. So sometimes your first guess is the right one. Other times you have to kind of work at it. So how about this? X squared plus 18x plus 72. Oh, geez, what numbers multiply to be 72, and which ones add up to 18? Ugh. So if you get to a problem and you're kind of stuck as to what to do and you're not quite sure what to, you've guessed and guessed and guessed, and you can't quite figure it out, I like to make a list. Or if you're not that strong with your math facts, if you didn't learn your times tables, this is a good way to go too. So what I do is I make a list of pairs of numbers that multiply to be the C value. So I'm going to list pairs of numbers that multiply to be 72. So I start off with 1 because 1 goes into everything. So 1 and 72. And then I ask myself, does 2 go in there? Yes, 2 goes in there 36 times. And then I ask myself, does 3? Okay, 3 goes in there, and if you're unsure, get out your calculator. It goes in there 24 times. 4 goes in there 18 times. Does 5 go in there? No, 5 does not go in there. So we move on to 6. 6 goes in there 12 times. Moving on, does 7 go in there? No. Does 8? Yes, 8 does. 8 goes in there 9 times. So move on to the next one, 9. 9 goes in there 8 times. Well, heck, I just duplicated a set of numbers that I already have. So rather than just keep on going forever and going to 10, 11, 12, 13, 14, once you get to a number that's already on your list, so I went from 8 and 9, then 9 and 8, once you see a duplicate, you're done. You don't even need to include that last one. So let me go ahead and, since they're the exact same, let's get rid of that last one. And this is my full list of all the pairs of numbers that multiply to be 72. So now I just need to figure out which of these pairs adds up to be 18. So let's go ahead and add those up. And it looks like 6 and 12 are the winner. They're the only pair of numbers that multiply to be 72, but add up to be 18. So that's my final answer. X plus 6 times x plus 12. So if you're ever struggling on which two numbers multiply to be this but add up to be that, make a list. Okay, let's try another one. X squared plus 3x minus 28. Ooh, pump the brakes. So far it's been all positive numbers. Now all of a sudden we have to deal with a negative number. So I need to find which two numbers multiply to be negative 28 and add up to be 3. Okay, this doesn't change our process. It just kind of changes the difficulty level a little bit. So let's start thinking, what numbers multiply to be negative 28? Well, there's 1 and negative 28. But here's the thing. When your C value is negative, you have to consider both options, either 1 and negative 28 or negative 1 and positive 28. Okay, 2 goes in there. So 2 and negative 14, also negative 2 and positive 14. 3 does not go in there. 4 goes in there, negative 7 times. And so then I also need to include negative 4 and positive 7. 6 doesn't go in there. 7 doesn't go in there. Oh, yeah, 7 goes in there. 5 doesn't go in there. But yeah, 7 does. So since I already have 7 on my list, I know my list is complete. So now let's go through and add these up and see which pair adds up to be 3. So negative 27, positive 27, negative 12, positive 12, negative 3, and positive 3. So we found it. We found the pair that adds up to be 3. So that's our answer, x minus 4 times x plus 7. Which leads me to my next idea, which is sign theory. So what sign theory, and I just call this, I don't know if any other math teachers call it this, but if you look at the signs of your original problem, what does that tell you about the two numbers you're looking for? So here's 4 examples, and you see that they look pretty similar in how they're written, okay? So in the first 2 problems, the only thing that's different is the signs. Same deal in the last 2 problems, okay? So I'm going to talk about how you know what the signs of the two numbers you're looking for are. So first thing I want to do is I want to check my C value first. So on the first 2 problems, the top 2, my C value is positive. I have a plus 15 there. So then what does that mean? If the C value is positive, it means that your signs match. Okay, so both numbers that you're looking for have the exact same sign. So then your next step is to check your B value. Okay, on this first one, my B value is positive, and on the second one, my B value is negative. So what does that mean? Okay, if my b value is positive and I know the two signs are going to match, then I know that my two signs are going to both be positive. So when I factor out x squared plus 8x plus 15, I'm looking for what two positive numbers multiply to be 15, but add up to be 8. Over here on the second problem, my b value is negative, and so that means the two numbers I'm looking for are both negative. So on this problem, I'm looking for what two negative numbers multiply to be 15, but add up to be negative 8. Because two negative numbers will multiply to be a positive, but add up to be an even bigger negative. So now that I know the signs of the numbers I'm looking for, it might be a little bit easier. So for 8, you might consider 3 and 5. So for the first one, x plus 3 and x plus 5. For the second one, it's going to be x minus 3 and x minus 5. Okay? So check your c value first. If the c value is positive, your two signs are going to match. And then your b value tells you what they are. Is it both positive or both negative? Let's take a look at the bottom two problems. Let's check that c value. On the bottom problem, the c value is negative. So what does that mean? It means the two numbers I'm looking for, it's going to be one positive, one negative. Okay? And if it's both one positive, one negative, it doesn't really matter what your b value is. Okay? You just know you're looking for one positive and one negative. So the answers to the bottom two are going to be x plus 3 and x minus 5, because positive 3 and negative 5 make negative 15. But when you add them up, you get negative 2. Over here on this one, I'm going to get negative 3 and positive 5 because those multiply to be negative 15. But a negative 3 and a positive 5 add up to be a positive 2. What I can tell you of your b term is the sign of your b term tells you the sign of your bigger number. So since my b term was negative here, my bigger number was negative. The sign of my b term here was positive, so my bigger number was positive. But that's just a fine detail. I'm not too worried about you knowing that. So to sum up, if we take a look at all the different ways we can have the signs, if both terms are positive, if both b and c are positive, that means the two numbers you're looking for are both positive. If your c is positive but your b is negative, that means you're looking for two negative numbers. Whereas if your c value is negative, it's just going to be one positive and one negative. And I'm not so concerned about your b value. Okay? That's the main idea I want you to get with sign theory. So let's try a few examples. Okay, so here we have a few examples. Let's just do a couple of them. On the first one, both of my signs are positive, so I know I'm looking for two positive numbers. So what two numbers multiply to be a positive 7 and add up to be a positive 8? Well, that's going to be 7 and 1. So I get b plus 7 and b plus 1. Let's take a look at number 3. My c value is negative, so I'm looking for what two numbers multiply to be negative 90, but add up to be 1. Okay, but one's positive and one's negative. So what two numbers are one digit apart on the number line, but multiply to be 90? Well, that'd be 9 and 10. So I got to get the right signs with the right numbers. I'm going to get m, let's see, a positive 10 and a negative 9 would give me positive 1. So m minus 9 and m plus 10. Okay, if we take a look at the third one here, my c value is negative or positive, so I know that my two signs match. The b value confirms they're both negative. So what two numbers multiply to be 9? Two negative numbers that multiply to be 9, but add up to be negative 10? Well, I think we're looking at n minus 9 and n minus 1. Okay? Now, I'll give you a heads up. The way to get good at this is just to practice, practice, practice. It might be a little bit clunky at first, but once you kind of get the hang of it, it goes rather quickly. And you can just look at a problem like number 4. That's going to be n plus 6 and n minus 2. You'll be able to just look at it and be able to do it. Okay? So one other thing I want to talk about, and it looks a little bit different. So let's get back to it. Okay, so take a look at this example. Now, the first thing that stands out to me is it's not in the right format. It's got a number in front of the x squared. So right away, I know I can't do FOIL factoring. So what other type of factoring can I do? Well, I think I've told you before that anytime you start a factoring problem, always check for a GCF. Okay, in this case, if I take a look at it, 3. 3 is my GCF. 3 goes into all 3 of those numbers. So I'll put the 3 out in front of the parentheses, divide everything by 3, and then I get 3x squared minus 3x minus 10. And from there, what's in the parentheses follows the right format. So I can take the x squared minus 3x minus 10 and factor it into x minus 5 and x plus 2. So if ever it doesn't look like it's in the right format, always check for a GCF. Okay? Again, the key to this is to practice. So practice a lot, do more than you have to, look up worksheets, and try to do as many problems as you can to get good at this. If you guys have any questions, please feel free to let me know. Either ask me in class or send me an email, and I'll be glad to help out in any way that I can. Have a good one, and I'll see you real soon.